Okay, now we proceed to question number 2, part C and D. We are given more information like that. What model will be proposed? Actually, when we look at this, okay, I just copy the first model that we have here. Okay, I just have this one. Okay, copy. So whether we still want to propose the same model or we want to change our model. Okay, if we look at here, when there is an intervention, the number of infected people is 20 less than if there is no intervention. Okay, that's the effect of intervention, and for every 1 person, okay. On the contrary, when there is no intervention from the government, number of people, okay, this is just the other way around from the statement up here. But then for every 1 person who recently returned, that 1 person who is suspected infects 5 other people, while up here only infect, not infecting anyone. So there is like different effect of the number of people who return from overseas on the number of infected people when there is an intervention compared to when there is no intervention. So then in this case we propose that there should be an interaction between those variables, that is the number of people who just recently returned from overseas and intervention or not. So that's why in here we will add that interaction term between x2 and x3. So that's my updated model based on the other additional information. We add this one because of this story. And now, what is the model fit? If you are asked the model fit, then it means that it is asked what is the value of beta naught, beta 1 and beta 4. Okay, just look at this story again. Okay, in the area, okay, for this we can say that the regression intercept is at y equals 2. It means that we have that beta naught equals 2. And then when there was an event with crowds, the number of people who are infected is increased by 50. Then it means that here we have that when x1 equals 1, y is 50 more than when x1 equals 0. So from this kind of information we have that beta 1 equals 50. And then from this story again we can say that when there is an intervention, okay, maybe we need to rewrite the model here so it's easier for us to compare. Okay, so when there is intervention, then the model is, when there is intervention means x3 equals 1, right? So then we change this with 1, and beta 3 times 1 is 1, and here also with 1. Okay, so we just leave it like that. And then if you want to write it in a simpler way, that is just the constant only, is the beta naught plus beta 3, and then the one with with x2, oopsie, the one with x2 is that beta 1. Okay, so here we still have that beta 1 x1, and then we have the one with x2 is we have beta 2 plus beta 4, right? There is with the intervention, the model with intervention. If there is no intervention, okay, if there is no intervention, okay, see, okay, we have it here. If there is no intervention, then the model would be like this. So no intervention means that, okay, it's easier to use the initial one. Okay, so if there is no intervention, it means that x3 equals 0. So here 0 times beta 3 just 0. Here whatever the value of beta 2, whatever the value of x2, but multiplied by 0 will just give us 0. So this is the model with the intervention and without the intervention. So then from this story, when there is an intervention from the government, the number of infected people is 20 less than if there is no interventions. It means that we are comparing, okay, it means that the same condition for x1 and x2, right? So then here we can say here 20 less than there is no intervention. So 20 less than no intervention. So we can say that beta 3, okay, so when there is an intervention, the number of infected people is less than 20. If there is no intervention, it means that here we have what's that differentiate between intervention and no intervention is in here. I mean regarding to the effect of intervention x3. So here, right? So it means that 20 is the value for beta 2 or beta 3. So here we have beta 3 equals less than, okay, when there is an intervention, beta naught plus beta 3, no intervention, beta naught, and in here is 20 less. Then if there is no intervention, then we have that beta 3 is minus 20. And then this information for every one person who recently returned. So this is the effect of x2, right? And only that one person is suspected to be infected. Okay, it means that only that person is infected, means that only that person will add to the number of infected people in that area, which means that in here we have that beta 2, beta 2 plus beta 4 equals 1. Okay, Now we go on here. On the contrary, there is no intervention. Number of people who got infected is 20 more than there is an intervention, means that beta node is 20, right? Oh, sorry, not beta node. Beta node only is 20 more than beta node plus beta 3. Okay, so just the same as saying this thing. Okay, and then we look at here. See, for every person who recently returned, that one person infected 5 other people, so that in total there are 6 more infected cases when there is no intervention. The effect when there is no intervention is this one. So this is just saying that beta 6, that beta 2 equals 6, and then beta 2 equals 6. From here we have beta 2 plus beta 4 equals 1. So we know that beta 4 should equal 2 minus 5, right? So then here, according to this model, then the regression fit is that we have up here that beta node equals 2, beta 1 equals 50. So then here we change it, beta node equals 2, beta 1 equals 50, beta 2 equals 6, beta 2 equals 6, beta 3 equals minus 20, beta 3 is minus 20, and then beta 4 equals minus 5 is minus 5. So that's the model fit, and the process is just like what I've explained before.